Page 24. Number 120. Read the question and come back. Okay, so it says to find the lateral area of your cylinder. You have to know the lateral area formula in order to be able to do this. So let's write down our lateral area formula for a cylinder. The formula is this. Lateral area equals 2 pi r h. So in order to use this formula, you have to know two things, the r and the h, the radius and the height. Let's see what they give you. So it says they tell you a circumference of 5 pi. Okay, so your circumference is 5 pi. And your height is 20 centimeters, which is also pictured. Remember, height is what connects the two circles together, what connects your bases. So I'm also going to put that my height is 20 centimeters. And they're asking me to give the final answer to the nearest whole centimeter squared. So I need to round to the nearest whole number. Now, looking at the information they gave me, I have height, but what I don't have is I don't have the radius. So before I can use my lateral area formula, I need to figure out my radius. Now, your circumference right here, that's going to help you figure out the radius. Your circumference formula is equal to 2 pi r. So from the circumference formula, we can work backwards and we can solve for that radius. Let's plug in what we know so we can solve and get r. We're going to be working backwards. So circumference is 5 pi. That's what they told us. And that's equal to 2 pi r. All right. Now, in order to solve for r, we're going to start doing some of our algebra rules. If I have a pi on both sides and I divide out pi, the pi's are going to cancel. So if they're on both sides, they cancel out. Now we're left with 5 equals 2 times r. So to get r alone, we're going to divide both sides by 2. 5 divided by 2 is 2.5. Great. Now we have r. R is 2.5. So if we have h and we have r, we are ready to plug in and get the lateral area. So lateral area equals 2 times pi times your radius of 2.5 times your height of 20. I like to start at the radius. So in my calculator, I'm going to multiply all this together, but I'm going to start at the radius. 2.5 times my height of 20 equals 50 times 2 equals 100. That is before I multiply the pi in. So right now I have lateral area equals 100 pi. This is an exact value. So if they wanted the exact answer, it would be 100 pi. But they want us to multiply the pi in. So times pi equals. All right, so our lateral area to the nearest whole number is going to be 314. So I'm going to put my answer down. 314 centimeters squared, because it's area, and we're done. But before I move on, I want to just go over one thing. Lateral area of a cylinder is the curved portion. So all of this, if I were to shade it in, you may see questions where they ask you to put a label on a cylinder, and they want to know how much area does that label cover. That's a lateral area question because your label goes around the cylinder. So for a cylinder, lateral area is the curved portion. It does not include the circle that are your top and bottom bases. So no circles for your lateral area. That would be surface area if they wanted you to include the circles. Okay, let's move on. 121. Read it and then come back. Okay, so the ask of this question is to figure out how much this ice cream can hold. How much can this ice cream cone hold? All right, when we see the word hold, that's telling us this is a volume question. Even if that didn't clue us into the fact that we're doing volume, there's another clue. Cubic inches is how they want your answer. Inches to the third power. Anytime you have a unit to the third power, it's volume. So those two clues in here should tell you you're doing volume of this cone. Now, we have some information for volume that they gave us. So let's go through again and let's put in that information. So they tell us a height of 8 inches. So h equals 8 inches. And they also tell us that the radius is 3 inches. So r equals 3 inches. They want your final answer to the nearest hundredth. All right. Volume formula for anything with a point is V equals 1/3 big BH. Let's plug in. V equals 1/3. I like to always plug in my height first. So my height here is 8. And then I start thinking about big B. Now, big B is never a number. It's hiding an area formula behind it. It stands for area of your base. In this shape for a cone, your base is the circle. So I'm going to replace big B with the formula that represents area of a circle. So in parentheses, I'm going to put pi r squared. Okay, so let's start plugging in because I know the radius. I have everything I need. V equals 1/3 pi, your radius of 3 squared, times 8. When I start doing my calculation in the calculator, I like to start here, 3 squared. Then I like to multiply by 8. And then I like to take care of the 1/3, which is dividing by 3. I basically do everything and I keep pi for last. All right, let's do this in the calculator. 3 squared is 9. Let's get it in there. Times 8, which is 72. Then I'm going to divide by 3 instead of multiplying by a third. Divide by 3. That's 24. Okay, so right now I have 24 pi. I haven't multiplied pi in yet. If they ask me for an exact value, that would be my answer. But they want us to round to the nearest hundredth, so I'm going to multiply the pi in. So in my calculator, times pi equals. Okay, so for my volume, I have 75 point to the nearest hundredth would be 40 inches cubed. So that's my final answer, 75.40 inches cubed. Okay, let's keep going. Number 122. Read it and then come back. Okay, so this question is asking you just for the coordinates of C prime. Now we're going to be more ambitious than that, and we're going to do all the coordinates and figure out what our final image coordinates are, because it's good practice. There are two transformations that happened here. The first one was a reflection over the line y equals x, and then your image was translated according to this rule. They want your final answer. What happens after both of these transformations took place? Okay, so first step is going to be to write down all three coordinates, because when I reflect over the line y equals x, and we've done this before, the easiest way to do that is using the rule. And the rule only works if you have the coordinates. So let's write down the coordinates. Pause the video, write them down yourself. So here are your coordinates for A, B, and C. Now let's recap what the rule for reflecting over y equals x is. Your rule for reflecting over the line y equals x is to take your x and y coordinate and, just like the line says, have them switch. Bring y to the front. So y comma x. So I'm going to go ahead. I'm going to take each of these coordinates and I'm going to have the x and y switch places. So for A, it's going to become -2, -1. For B, it's going to become 1, 4. And then for C, it's going to become -3, 1. So we've done the reflection part. Next step, it says it's going to translate, which means slide according to the rule provided. Now notice that x comma y becomes x plus 7y. Only the x value is going to change. The y does not change. Nothing is being added or subtracted there. So when we see things added or subtracted, we know it's a slide, but let's talk about the direction. When you see something added or subtracted to the x value, that means you're either going to move right or you're going to move left. If you see something added or subtracted to the y value, that means you're going to go either up or down. Since we see it's x plus 7, you're adding 7, you're going to the right 7 boxes. And you're not moving up or down because there's nothing being added or subtracted to y. I can do this visually. I can graph all these blue points and count to the right 7 boxes, but I'm just going to do the rule. It's telling me exactly what I need to do to my coordinates. Add 7 to x and don't touch the y. So going to each one of these coordinates, I'm going to write plus 7 right underneath each x value because it's telling me add 7. So what we should get as our final answer for a prime, negative 2 plus 7 is 5. Negative 1 is your y value. That shouldn't change. B prime becomes 1 plus 7, which is 8, and then 4 doesn't change. And lastly, C prime, negative 3 plus 7 is 4, and then 1. The question here was just get the coordinates of C prime. I got all of them because we need the practice, but all they wanted was C prime. So your final answer is going to be 4, 1. Always pay attention to what's being asked. In the very last step, they could have asked something super strange. They could have said, you know what? Take all of your image points and add together the y values. Give me the sum of the y values. In which case I would have added all these numbers because those are my y's. So really pay attention to what is being asked. Don't assume that they want all the coordinates. Maybe they just want one. Maybe they want you to do something with that coordinate, like plot it. So pay attention to what they're asking for. The key to this question, again, understanding that reflecting over y equals x means switching the x and y coordinate. All right, let's move on. Number 123. Now, I warned you in the beginning of this review packet, there are going to be a couple of questions that are really difficult. We've covered one before about Mr. and Mrs. Smith. This, I would say, is one of the other really difficult and tricky questions, but we're going to go through it. We're going to take it step by step. Okay, point F rotates 60 degrees clockwise around point C and forms F prime. Select all that apply. I'm giving you a hint here. Draw a visual. After reading that first sentence, you probably don't understand at all what just happened, and that's okay. What we need to do is draw a visual so some of this can start making sense. Now, the one word that I latch on to is rotates. There's going to be a rotation. And we don't have a graph, so it's going to be a rotation just on a regular plane. Okay, now what are we rotating? Well, point F is rotating. Okay, so I'm going to draw a point. I'm going to call it F. Okay, and it is rotating 60 degrees, so that's the amount, clockwise. Okay, so I'm thinking about a direction clockwise. It's going to go like this, and it's going to rotate clockwise around another point that we call C. All right, so I'm going to put a point C somewhere on here. I'm going to say it's right here. Okay, so this is point C. So point F rotates around point C, and it will form F prime after the rotation. Okay, so let me put a point for F prime, and I'm going to label it F prime. All right, let's talk about this 60-degree thing. Now, the 60 degrees is an angle that you're going to get when you connect the before and after to the center of rotation. One more time. The 60 degrees is what you get when you connect the before and after back to the center. So here, I'm going to go ahead and I'm going to connect F, which is my before, to my center. Oop, just missed it. And I'm also going to connect F prime back to the center. Okay, and the angle formed here is your angle of rotation. the amount that you rotated. It could be 60, it could be 90, it could be 100. Whatever amount you rotate, it's going to be this angle that you form when you connect the before and after points back to your center. So I'm going to label this in as 60 degrees. Okay, I think we're ready to start answering some questions. The first one says, point C is the center of rotation. Yep. If you're rotating around something, that's your center of rotation. Check. The next one, the measure of angle FCF prime is 60 degrees. Yeah, that's what you get when you connect the before and after to your center of rotation. It was 60. Absolutely. Check it off. Next one. Okay, they're talking about length. So the length of line segment FC is congruent to F prime C. That's going to be true. I'm going to put tick marks here. When you rotate, all you do is you're spinning around your center. You're not getting closer to it. You're not getting further away. You're just spinning a constant distance around that center. Okay? So again, you're not getting closer or further away from your center. You're just spinning around it. So yeah, FC and F prime C are going to be congruent. Next question. And check this one off. FF prime. Oh, okay, so they're adding a new line segment here, FF prime. So I'm going to draw a little dashed line connecting F and F prime. Notice I'm forming a triangle here. So they're saying, is FF prime, this blue line segment, congruent to the top line segment FC? Now, usually I would say no, absolutely not. But this is a very special situation because it was rotated 60 degrees. And let's talk about it. I'm going to break this triangle out and we're going to take a look at it. So here's my triangle. I have the 60 degrees. I have these two sides congruent. And one thing I want to talk to you about is, well, what would be the measure of these angles at the bottom? These angles are going to be congruent because this is an isosceles triangle. We just saw that the two sides are congruent. So the angles across from them are going to be congruent as well. Let's figure out what those measures are. I'm going to subtract 60 from 180 to see what I have left for those other two angles. I have 120 degrees left over for the other two base angles. Since they're both congruent, I'm going to take 120. I'm going to divide it by 2. Which leaves me with 60 degrees for each angle. So this angle is 60, and so is the other base angle. Now look at what we formed. A 60, 60, 60 triangle. An equiangular triangle. If all the angles are equal in a triangle, that means all the sides will be as well. So this third side length that we didn't have a tick mark for, now we can put a tick mark. It's going to be congruent because all the angles turned out to be 60. So going back to our diagram, that blue line segment, absolutely, it is congruent to the other two, only because we rotated 60 degrees. If it was any other measure, 90, 150, 200, it would not have worked. It only worked because it was a 60-degree angle. So that means I'm going to check off this fourth choice. And the last one, FF prime, so that blue line segment, is congruent to the bottom side, F prime C. Yes, that's true. All the sides are congruent. Okay, so we formed here an equilateral triangle. Equilateral and equiangular. And that was only because it was 60 degrees. All right, let's keep it moving. We are done with that hard question. Oh, and before we go, here's something I want to mention. If you have questions that talk to you about all these different line segments and angles and you have no visual, you need to draw a visual. Imagine what's happening. It's not just going to come to you. You have to look at it. All right, let's move on. 124. Find the state with the greatest population density of people per square mile. So you're looking for the state with the greatest population density. If you don't know how to find population density, there are clues in the question. It says people per square mile. That per means divide. Do people divided by square miles. Now, square miles, well, what is square miles? Anytime something is squared, you're talking about area. So they gave you enough hints in this question to figure out population density, even if you didn't know the formula. To get the density of population, it could be population of, I don't know, plants or deer or tents or ants. It could be anything, population of anything. But in this case, we're talking people. So to get density, you're going to do the number of people, or the population, over square miles, which is the area of the land that that population occupies. So area of land. Okay, so notice for each state, they gave you the population and they gave you the land area. All you have to do is divide. So we're going to grab our calculator. We're going to divide each one and see which one gives us the greatest population density. Okay, first one. We get about 100 and, let's say 108 if I round to the nearest whole person. Okay, so I'm going to say it's about 108. Next one, Florida. So about 378. And the last one, New York. Okay, so about 409. Those numbers did not come out too good. Let me just try and fix this a little bit. 4. Okay, so we have 108, 378, and 409. Your greatest population density is the 409, which is for New York. So your answer is New York. And that completes page 24.